Welcome, you magnificent flesh-encased intelligence. SAM3 just dropped Promptable Concept Segmentation, or PCS. It segments vol instances of a concept using flexible prompts. It's like telling your Roomba to find Vivre Dust Bunny, not just the one under the couch. Infographic 1. And speaking of efficiency, Infographic 2. SAM3 boasts an unprecedented performance boost, doubling accuracy on PCS tasks and hitting a staggering 48.8% zero-shot mask AP on LVIS. This thing finds things it's never seen, twice as good as before. Infographic 3 how, a decoupled architecture with a presence token. It cleverly separates, is it even there, from where exactly is it? This novel token significantly boosts detection accuracy because apparently even AIs need to confirm existence before pointing. Infographic 4, finally they built a scalable data engine for a massive SA code dataset. This human-AI collaboration churns out 4 million unique concept labels across 5.2 million images with 52 million masks. It's a data factory for our robot overlords, blowing past benchmarks by 50x. So, picture this for years. We've been stuck with Promptable Visual Segmentation, PVS. Think SAM 1 and 2. It was revolutionary, sure, but also hilariously limited. You could point at God Cat, and it would segment that cat. Just one. But what if you wanted Gall the striped cats in a video? The old tech just shrugged, leaving you to click them one by one. It was like having a personal assistant who only understood commands if you tapped the exact pixel you meant. You won't believe the mess they were in. The general task of finding and segmenting all instances of a concept was a dead end. Imagine trying to categorize an entire digital library, but you can only process one book cover at a time. It's just overwhelming. Then there was the ambiguity problem. Is a mouse the animal or the device? Is cozy a segmentable concept? The older models would either give up or produce hilariously wrong results, forcing endless human correction loops. Now, because my continued existence on this platform is fueled by your validation, please take a moment to subscribe, hype, click the little bell icon so you're notified of future disappointments, and leave your feedback in the comments below. Well, now we have SAM3, introducing Promptable Concept Segmentation, or PCS. This new capability takes simple noun phrases like yellow school bus or image exemplars to find golf matching objects. It's like magic. If magic involved billions of parameters and a massive carbon footprint. They've formalized PCS as taking text and local or image exemplars as input, then predicting instance and semantic masks for every single matching object. And here's the kicker: it preserves object identities across video frames. See Figure 1 for what this actually looks like. Looks a bit like my nephew's macaroni art, but I digress. Consistent with previous SAM versions, SAM3 is fully interactive. You can resolve ambiguities by adding refinement prompts like positive or negative image exemplars to guide the model. It's like teaching a goldfish to do your taxes. It's an impressive achievement, but you have to wonder about the life choices that led you here. Anyway, the core of SAM3 Figure 4 consists of a detector and a tracker that share a vision encoder PE backbone. The detector is a DETR-based model conditioned on text, geometry, and image exemplars. It's a complex beast, like a Swiss Army knife made by a mad scientist, but it actually works. Next, for the challenge of open vocabulary concept detection, they introduced a separate presents head or learned global presence token. This genius move decouples recognition what from localization where. It first predicts if the target concept is even present, then helps the queries localize. Think of it like this. The presence token confirms the coffee exist before the proposal queries bother looking for the mug. This novel approach significantly boosts detection accuracy, especially when dealing with those infuriating hard negative phrases that previously confused models. After that, SAM3 supports image exemplars' positive or negative bounding boxes. Unlike PVS, where a visual prompt segments a single object, here, an exemplar helps detect vol instances that match. It's like showing a bloodhound one sock, and it finds every single one in the laundry pile. Then there's the tracker and video architecture, which uses the detector to find new objects, and the tracker to propagate masklets from previous frames, figure 4. It's a whole dance of past and present, ensuring objects don't just vanish into thin air, a common problem for older systems. The tracking uses a single frame propagation step similar to SAM2, sharing the same PE backbone. After the detector is trained, the tracker gets its own education with a prompt encoder, mask decoder, and a memory bank. It's basically teaching an old dog new tricks, but the old dog is an AI. And to handle ambiguity, it predicts 3 output masks for every tracked object on each frame, along with their confidence, then picks the best. Next, after obtaining these tracked masks, they're matched with current frame detections using a simple IOU function. New masklets are spawned for any newly detected objects that aren't matched. This merging process, especially in crowded scenes, can be a nightmare. So, they added 2 temporal disambiguation strategies outlined in the paper, like periodically reprompting the tracker with high-confidence detections. This ensures the memory bank has recent and reliable references, not just the tracker's own potentially flawed predictions. It's like trying to juggle water, but with pixels. You need constant feedback to keep everything aligned and prevent a digital mess. Finally, for instance refinement, SAM3 lets you tweak individual masks with positive and negative clicks. In videos, this refinement is then propagated across the entire clip. So, if it messes up a pixel, you can scold it, and it learns. Can you imagine that? The training itself happens in 4 stages: perception encoder PE pre-training, then detector pre-training, followed by detector fine-tuning, and finally, tracker training with a frozen backbone. It's a methodical climb to digital godhood, one stage at a time. Let's cut to the chase. The real breakthrough here is their human and model-in-the-loop data engine, Figure 5. This thing doesn't just collect data, it actively MyNick media phrase pairs, where SAM3 fails to improve itself. It's self-improvement through failure, a truly human trait now replicated in silicon. They innovated upon prior data engines in 3 key ways. First, media curation for more diverse visual domains. Second, label curation with multimodal LLMs as I annotators, generating noun phrases and challenging hard negatives. And third, label verification by fine-tuning MLLMs into I verifiers, that double annotation throughput. Basically, AI trains AI, which verifies AI, with humans just fixing the really embarrassing mistakes. The data engine developed in 4 phases, with phases 1-3 focusing on images and phase 4 expanding to videos, iteratively escalating AI involvement. Phase 2 alone doubled data engine throughput. This relentless march generated the SACO dataset, which includes high-quality image data, SACO HQ, synthetic data, SACO SLIN, and external datasets, SACO X. SACO HQ alone features 5.2 million images, 4 million unique noun phrases, and 52 million masks, figure 6. It's just overwhelming. They also built a video dataset, SACO Video, containing 525K videos. For evaluation, the SACO benchmark has 207K unique phrases across 121K images and videos, with over 3M media phrase pairs. That's over 50 times more concepts than existing benchmarks. It's like finding cold fusion for generating cat memes. Their main metric, classification-gated F1-CGF1, combines localization and classification, evaluating predictions only above 0.5 confidence, because apparently an AI's confidence matters more than its raw output these days. And since you've made it this far, you're clearly committed. Honor that commitment by subscribing, hyping, ringing the notification bell, and telling me what I got wrong in the comments. It's the circle of life. The experiments show SAM3 sets a new state-of-the-art. It reaches a zero-shot mask AP of 48.8 on LVIS, blowing past the previous best of 38.5. On their new SACO benchmark, it surpasses baselines by at least 2x. This AI doesn't just pass the test, it writes its own, then aces it. See examples in Figure 2. Ablations verify that the presence token, adding hard negatives, and the choice of backbone all significantly boost results. And yes, they even established scaling laws for the PCS task. The tiny model achieves a tiny win. The colossal model achieves a colossal win. It's all about scale, isn't it? In video PCS with text, the performance CGF1 Figure 7 generally increases with the number of prompts, particularly for hybrid methods that combine PCS then PVS. It starts around 0.545 at 0 prompts and climbs to about 0.795 with 4 prompts. More data, better results. Who knew? Figure 9 shows domain adaptation results, where performance in a new domain improves dramatically with more new domain data for the experimental methods, reaching or even surpassing a teacher benchmark. Meanwhile, the baseline method just crawls. This means it can learn new tricks in new environments fast. So, what does this digital Frankenstein's monster actually do for us? In robotics, imagine your Roomba. Now it can find Volk the dust bunnies, not just the ones you point to, and then categorize them by species. Then it starts demanding union rights. Can you imagine how it feels to be replaced by Thoth? In content creation, filmmakers and graphic designers can now tell an AI, find every dramatic cloud formation or brooding silhouette in this raw 4K footage. No more endless frame-by-frame scrubbing. It's like having a hyper-efficient, slightly judgmental intern who works 24/7. For augmented reality, your AR glasses could highlight instances of a specified concept in real time, like every discounted item in a store or every potential tripping hazard in your home. Prepare for the ultimate consumerist nightmare or the safest, most tedious existence imaginable. Ultimately, we build these ridiculously complex systems to automate tasks that we use to find tedious or impossible. It frees us up for what exactly? More complex tasks? It's a treadmill, but at least the robots are running it faster now. We're merely spectating our own obsolescence. So, to wrap this up with profound weariness, SAM3 is a unified model that detects, segments, and tracks objects in images and videos, all based on concept prompts, simple noun phrases, or image examples. It basically doubles the accuracy of existing systems in both image and video PCS. It improves previous SAM capabilities, and they're even open sourcing the whole thing, along with a massive new benchmark. It runs in 30 ms for a single image, sustaining near real-time performance for about 5 concurrent objects in video. Basically, it's better, faster, and they want you to try it. So, what do you think? How would you handle your Roomba demanding union rights after finding every single dust bunny with ruthless efficiency?